We're going to move into the next chapter, chapter 7, which is about a new topic called hypothesis testing. And we're going to look at a procedure called a t-test. Basically, this is a formalized procedure to make a comparison between two population means. Now, we already have a procedure that does compare two population means, and we can do that with a confidence interval. That's the confidence interval for the difference in means. With a confidence interval for a difference in population means, we saw that the number 0 played an important role. That was from chapter 6.6, 6.7. In essence, when that resulting confidence interval contains a 0, that implies that the difference, well, there is no difference. That implies that the two population means potentially could be equal. It does not prove they're equal, but it supports that claim. If the confidence interval for a difference in means does not contain 0, then that implies that there is a significant difference between the two population means that we are comparing. So this confidence interval for a difference in means can either result in a interval that contains 0. So if this difference resulted in a 0 in the confidence interval, that implies that those two population means could be the same. Or these population means could be different, right? That would be when the confidence interval does not contain 0. So if the confidence interval has 0, that could imply that the population means are not different. And this is when the confidence interval does not contain 0. So we already have a tool that allows us to compare population means, and that is by looking at the confidence interval for the difference in those means. So this new process, it's called a hypothesis test. We're going to look at different versions of hypothesis tests in the future. This one is called a t-test. It's often just called a t-test, but to be more specific, it's called a two-sample t-test because we're comparing two samples. And this is a way or a procedure that allows us to formally compare two population means. And the general idea is to create a hypothesis. Typically, that hypothesis is that mu1 and mu2 are different. But then we want to test that hypothesis. So then we analyze sample data to see whether that sample data provides sufficient evidence in support of that hypothesis. So that's going to conclude this video, and in the next video we're going to see the steps required to perform this analysis. So there's going to be some formulas. We're going to see how do we construct this hypothesis, and what does it really mean when we say that there is sufficient support. Because notice I didn't say the word prove, not in this written statement at least. So see you in the next video.